Our mission to Mars takes place sometime in the future when a sightseeing trip to the Red Planet is an everyday adventure. When you enter, please use all 3 aisles. Keep your group together and move as far toward the end as you can. Excuse me. Mr. Johnson, all the passengers for Flight 295 are now in the boarding area.
Thank you. Welcome to Mission Control, space travelers. The first part of your trip to Mars today will be directed from this room, and so will your landing when you return to Earth. As you can see on the large screen behind me, we're keeping track of things on one of our many manned space stations now in orbit, while the small screens below show other activities being monitored by Mission Control. I'll have them repeated on the upper screens for you also.
SSL, this is instrumentation.
Roger. SPO, start port recorders and TV video tape recorders.
Welcome.
Now on the large screen again, you see a scientist aboard the space station at the controls of a large telescope trained on the sun. This kind of solar research was begun back in the early 1970s by the Skylab astronauts. And time-lapse pictures from space like this are revealing new facts about how the sun produces energy, which may help us solve some of our own energy problems on Earth. This is a very interesting part of the station, where special manufacturing processes are carried out under weightless conditions. Here you see a close-up picture of a groove being melted in a stainless steel plate. Done in zero-G conditions, this imparts a quality to the metal we can't get under Earth gravity.
Mission Control, this is Spacelab 09er. Stand by for new video on B channel.
And now, through an onboard microscope and time-lapse camera, we can see the way crystals form in zero-G.
Capcom, this is Spacelab 09er. Request you transmit this recording to Crystallography Lab, Huntsville. Over.
09er, this is Capcom. Roger your request. Relay coming up will be via Goldstone. Capcom out. 09er out.
These space-grown crystals are so pure that they're going to bring revolutionary advances in electronics, which will benefit every one of us. In fact, they're so...
Attention. Clear all channels for possible emergency re-entry.
Oh, no, not again.
Stand by. Video signal coming in on all channels.
Just as I thought. Somehow, this silly bird trips the emergency system every time he comes in. And I think he knows the laugh's on us.
Oh, Mr. Johnson, would you show us what it's like for people in zero gravity? That's very interesting.
Of course, just a moment. Patch us into Skylab Video Net, please.
Roger, Mission Control.
Now, there you see how easy it is to get from one place to another. You simply float through the air. That takes some getting used to. But zero-G has other advantages, too. Like this, for example. One man can easily handle heavy pieces of scientific equipment that he couldn't even move under normal gravity. Astronauts quickly adapt to zero-G, but over extended periods, regular exercise is absolutely vital. Here are some off-duty crew members working out in the station gymnasium.
This is JSC Medical. MX leads are now being monitored on channel 27. For this exercise period, all ECGs normal. Heart rate, 120 plus.
It's fun, but it isn't always as easy as it looks, as you can see. With a little practice, though, you can do tricks that would make a circus acrobat turn green with envy.
All personnel switch to channel number 2 for status check.
Port communication status is go.
Instrumentation.
Instrumentation, go.
Propulsion.
Flight 295 to Mars is now ready for boarding at gate number 3. Go.
SPO.
Go.
Now on the large monitor, you can see your spacecraft waiting on the launch pad. Countdown is in progress and all systems are go. Have a good flight.
Ladies and gentlemen, welcome aboard our McDonnell Douglas DC-88 Spaceliner for today's mission to Mars. The captain has asked that you remain in your seats at all times. And please, no smoking.
Attention, please.
Folks, this is Third Officer Collins speaking. I'm your tour guide today, and I'll be telling you about what's going on during the trip. Right now, we're on final countdown, and you can watch our liftoff on the lower screen in your cabin. I'll speak to you again after we're in space.
Mission Control, this is Mars 295, ready for departure. 295, roger. Countdown is go at T-minus 5, 4, 3, 2, 1. Ignition. Hyperspace penetration. Good luck. 295.
Ladies and gentlemen, we've just dropped our booster engines, and in a moment we'll make what we call a hyperspace jump, the new method of space travel which enables us to cover enormous distances in seconds. On the side screens, our ship's computer has drawn a diagram of our solar system, and we'll tip it over and move in closer so you can see where we're going. You'll notice that the orbital velocity of the planets is exaggerated, but as we approach the inner planets, you can see that they move with the proper relative speeds. Earth and Mars are anywhere from 35 million to 240 million miles apart at times, which used to make a trip to Mars pretty tricky. For example, spaceships had to follow a curved path for about 8 months to intercept Mars when it reached a certain spot. It was like having to hit a golf ball in California hard enough and accurately enough to make it go through one particular window of a train arriving in Florida that much later. Today, it's much easier. We simply launch out into space until we reach Mars Acquisition Velocity, or MAV. Then we generate a hyperspace field around us for a short time. When we switch it off, our spacecraft is approaching Mars. Back in the 70s and 80s, this would have seemed like science fiction, but today it's routine, and we...
Attention all stations, hyperspace penetration now commencing. Secure all ship operations. All stations, we are now in normal space mode. Resume all operations.
Well, folks, a hyperspace jump is always interesting, to say the least. But we're back in the real universe again.
Attention all stations, outer lock is now open. Stand by to launch camera drones.
Those small unmanned rocket ships you see leaving us will shortly be sending back television pictures as they fly near the surface, but we'll continue our view from orbit also. Through telescopic lenses, Mars looks even more barren, and there's definitely no sign of it being inhabited. As we know now, some things once thought to exist on Mars turned out to be only illusions, such as the famous Martian canals. But it does have some natural features that are almost as amazing. For example, this gigantic rift in Mars' surface called Mariner Valley. It's over 3,000 miles long, 10 times bigger than the Grand Canyon back home. And for a planet that's only half the size of Earth, that's pretty impressive. This superimposed outline of the United States will give you an idea of its size. Here's a closer view of the section of the rift one of our camera craft is approaching. In a few seconds, we'll have the picture it's sending back, so watch the side screens, please. There's the picture. Our camera ship is down in the rift now. Seen this close, it looks quite Earth-like, but it's hard to get the scale of things. The wall there is almost 4 miles high, and the floor is about 50 miles across at this point. Even those branch canyons you see are 6 or 7 miles wide and go back as much as 100 miles from the main rift. This is no little canal by any means. On the upper screen, we're switching to what is literally the high point of Mars, Olympus Mons, the biggest volcano in the whole universe, as far as we know now. It's 370 miles wide at the base and over 75,000 feet high at the top, 2.5 times more than Mount Everest, the highest point on Earth. Now on the side screens is the picture from our other ship as it approaches the top of the cone. In just a moment, it'll drop down into the caldera, and you can see how big it really is. On Earth, the largest calderas are up to 10 miles across, but that's 40 miles to the opposite rim. Olympus appears to be extinct now, but just imagine what it was like when that entire area was a sea of boiling lava. Scientists estimate it was... Just a moment, please.
Spacecom, we show a loss of signal on remote 2. Impact count is rising.
Ladies and gentlemen, our camera ship has been knocked out of control by a shower of meteoritic particles. We may encounter the same conditions and...
Spacecom, this is operation. We have damage to primary ACS.
Emergency. Stand by for space warp.
Ladies and gentlemen, we're returning to Earth immediately. Be prepared for another space jump.
Mission Control, this is Mars 295. We are terminating emergency space warp. Are we cleared straight in? 295, this is Mission Control. Affirmative, your last transmission. You are priority 1 for descent. Auto control is locked on, and we are counting to retro fire. 295.
Ladies and gentlemen, as you can see, we'll be on the ground soon. Everything's all right now, but that was a close call. Actually, the chances are 1,000,000 to 1 against meeting another emergency like that, so please fly with us another time. There's a lot more to see on Mars. Now, please stand by for touchdown.
Ladies and gentlemen, the outer locks are now open and you may leave the spacecraft. Thank you for flying McDonnell Douglas today, and we hope to see you again soon.